Have you ever been puzzled by template argument deduction in C++? It can be quite tricky, especially with the new features introduced in C++17. If you're feeling confused, you're definitely not alone. Today, we're diving into the gotchas of template argument deduction for class templates. I totally get it. The intricacies of template argument deduction can leave even seasoned developers scratching their heads. You're not the only one who has faced these challenges. Many have found themselves stuck trying to understand how these templates work. Let's take a look at a specific question that came up. One user asked, if I instantiate a template with an R-value reference, will that overload always be called? They provided some code that really highlights the confusion around this topic. Sound familiar? Let's break it down together. So what's happening here? The user is trying to understand the behavior of different overloads when using template argument deduction. The key point is that the second overload, which is a forwarding reference, will not be preferred over the first one, which is an R-value reference. This can lead to unexpected behavior. And stick around. At the end of this video, I'll share some additional gotchas and style guidelines that can help you navigate template argument deduction more smoothly. To address the user's first question, when instantiating the template with an R-value, the R-value reference overload will indeed be called. This is because the first overload is a forwarding reference, which allows it to bind to R-values. For the second question, the user is correct that the last overload cannot be called without explicitly specifying the type parameter. This is due to the way template argument deduction works in C++. Next, the user should be aware of some additional gotchas. One important guideline is to ensure that the types used in the template are compatible with the intended operations, as this can lead to unexpected behavior. Finally, regarding user-defined deduction guides, they must be placed after the class definition. The user cannot have a trailing return type in the constructor declaration within the class definition itself. Fun fact, did you know that template programming in C++ can sometimes feel like solving a puzzle? Each piece must fit perfectly, or the whole thing just doesn't work. But don't worry, we'll help you fit those pieces together. Now, let's look at the answers provided by other users. The user clarifies that the second overload in the constructor is not a forwarding reference, which is an important distinction. When instantiating with an R-value, the R-value reference constructor is preferred, leading to the correct specialization of the class template. They also confirm that the last constructor cannot be called without explicitly specifying the type parameter t. This is because t is in a non-deduced context, which is necessary for conversions. Finally, the user states that user-defined deduction guides must be placed after the class definition, as per the rules. They also mention that trailing return types in constructors do not apply, since constructors do not return values. Here's a pro tip. Always be mindful of the overloads you define and how they interact with template argument deduction. This awareness can save you a lot of headaches down the line. And there you have it. Understanding template argument deduction can be challenging, but with these insights, you're better equipped to tackle it. If you found this video helpful, don't forget to subscribe for more tips and tricks on C++ programming.